All right. We're going to take a look at 1.5 today, infinite limits. So determine infinite limits from the left and from the right. Find and sketch a vertical asymptotes of a function or graph of a function. All right, let's say, for example, you have a vertical asymptote. Well, we'll put it right here. You have one right here at A, and you have another one right here. We're going to say this is B. And let's see your graph looks something like this. Doesn't have to be exact, but we're just trying to get the general idea here, right? Awesome. So the limit as x approaches A from the left of f of x. Limit as x approaches A from the left. So I'm coming like this. What is that approaching? That is approaching positive infinity. Now, we can't say that that's a specific number. Can't identify it as a specific number, so we say it does not exist. So the limit as x approaches A from the right of f of x. So this time, I'm coming from the right. That's also going to be positive infinity. As we just talked about, does not exist. Now, the limit as x approaches A of f of x. Now remember, this has to be the same thing on both sides, like we talked about in 1.4. This is positive infinity, but we're going to say it does not exist because, well, we don't know what it is. Now let's take a look at B. The limit as x approaches B from the left. So we're coming down like this. That's going to, of f of x. That is going to be approaching negative infinity, which does not exist. From the right, again, D and E. And lastly, the limit as x approaches B of f of x is negative infinity, which is just does not exist. Okay, let's take a look at a couple things here. Finding vertical asymptotes. H of x equals f of x over g of x if g of c equals 0 and f of c is not equal to 0, then a vertical asymptote will occur at x equals c. Now here's some examples. Find a vertical asymptote and determine one-sided limits at those asymptotes. Factor the numerator. So the x plus 2's divide out. So we have a vertical asymptote of x equals 2. Now, what's going to happen when we approach that asymptote? Remember, this is at x equals 2. When we approach that asymptote, first thing I'm going to do is I'm going to approach it from the left. So what I'm going to do is I'm going to put values in that approach 2 so I get a sense of what's taking place. So I'm going to use -1, 0, 1, and 1.5. If I put these numbers in, if I put -1 in to here, I am going to end up with 4/3. If I put 2 in, I end up with 3 halves, or excuse me, 0, I end up with 3 halves. If I put in 1, I get 2, And if I put in 1.5, I end up with 3. So as you increase the value of the x's, the y values also increase. So what that tells me is that the left side is going to look like this. So as the function approaches 2 from the left, f of x is going to approach positive infinity. Now what we're going to do is we're going to take a look at what happens when I approach 2 from the right. Again, we're just going to set up a table to do this. Five, 4, 3, and we use 2.5. If I put in 5, I get 2/3. If I put in 4, I get a half. If I put in 3, I get 0. And if I put in 2.5, I get -1. As my x values approach 2 from the right side, what has happened to the y values? Well, those y values are decreasing. So what that means is that my function is going to look like this. So that tells me that approaches negative infinity. They're not approaching a specific number. Remember, this is about the journey, not the actual destination. And what we get is that this function, as it approaches, does not exist because they're approaching two different things. Here's another one. I'm going to go ahead and factor that denominator. I end up with x plus 2 times x minus 1 in the denominator. So I have vertical asymptotes at -2 and 1. I'm not going to graph it, but what I am going to do is set up a table that looks at these. So this first one is I'm going to take a look at approaching -2 from the left. So if I put -5 into that, what you get is -5/18. If I put -4 in, I get -2/5. And if I put -3 in, I get -3/4. So what's happening to my y values? They are decreasing in value. So as x approaches -2 from the left of f of x, that is going to approach negative infinity. So that means it's going to look something like this. Now we're going to take a look at in between them. Actually, yeah, this table will work for to the right of -2 and to the left of 1. If x is 1, y is a half. If x is 0, y is 0. If x is a half, y is going to be -2/5. Now let's take a look at the limit as x approaches 1 from the left. So if this is going towards positive infinity, that means this is going to be going towards negative infinity. So what that means is that, I'll put it right here. Here's -2, here's +1 as far as your asymptotes. That means it's going to look like that. Your graph is. Now let's take a look at the limit as x approaches 1 from the right of f of x. If x is 4, y is 2/9. If x is 3, y is 3/10, and if x is 2, y is 1/2. So these values are increasing, which means that's going to be approaching positive infinity. Again, all I'm doing there is I'm just putting these values into the function. Okay, here are a couple trig functions. Now, if you have f of x equals cosecant of 2x, that's the same thing as f of x equals 1 over sine 2x. Now, what we're looking for, where does that equal 0? That's what we're looking at. So where does sine go, or where is it going to equal 0? So we know that sine equals 0 at 0, pi, 2 pi, 3 pi, and so on. Now I'm going to divide that by 2 because I have a 2 right here. So what that means is where it equals 0 is going to be at x equals 0, pi over 2, pi, and 3 pi over 2. Now why is that important? Because that's where our asymptotes are, right? So at every pi over 2n, where n is an integer, you are going to have an asymptote. So that gives us an idea what our graph's going to look like. All right, so now what we have, f of x equals tan 4x. Well, this is really the same thing as f of x equals sine 4x divided by the cosine of 4x. And we want to set that equal to 0. So cosine x equals 0 at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2, right? But now I have 4x, so I got to divide that by 4 because this is going to, there we go, divide it by 4. Your asymptotes are going to occur at pi over 8, 3 pi over 8, 5 pi over 8, and 7 pi over 8. So what that means is x equals pi over 4n plus pi over 8. That's where your asymptotes are going to occur. Okay, here's a real life application of this. The given function estimates C in millions of dollars, or in millions, to seize X% of illegal drugs. Estimate the cost to seize 50%, 75%, 90%. What these values suggest about the cost of seizing illegal drugs as the percentage approaches 100%. According to this function, can 100% be seized? So what we have is this function. C equals 550 divided by 100 minus x. Now that's just a function we just made up, or I just made up. we know that 0 has to be less than or equal to x, which is less than 100. That's our domain. So then if I have C of 50, again, that's going to represent 50%. That ends up being $11 million. C of 75% is going to be $22 million. Again, we're just putting this function in, putting these numbers in the function. So that's the cost of seizing the drugs. As the percentage increases, the cost to seize them also increases. So what we have is we have this limit. And that limit is as x approaches 100% from the left of 550 divided by 100 minus x. What does that approach? Well, that is going to approach positive infinity. If it approaches a positive infinity, not a specific number, what does that mean? That means it does not exist or you cannot do it. So we have vertical asymptote at x equals 100. And therefore, not all 100% of illegal drugs can be seized. All right, that's going to wrap it up for 1.5.